All right, folks, let's go and get started. Welcome. I'm glad you're here. So this is me. I'm Erik Gross. I'll be your instructor today. I am an experienced senior level software developer and all-around nerd. Ooh, yeah, absolutely. It's been a while since you used JavaScript, Robert. Yeah, it'll be a cool little refresher. I'm a veteran. I was in the Navy for about 6 years, and I'm the co-founder of the Tech Academy, along with my business partner and tremendous friend, Jack Stanley. Okay, good. Don't pass that on, Regina. His head will get too big. No, I have a fantastic partner. All right, class rules. We have a class assistant, Regina. She's here to watch the chat, monitor it, answer questions. She's run hundreds of free classes on her own and is here as the assistant, so she can handle a lot of things. Be nice or she'll boot you. We don't really have a problem with that. It's awesome. I want to point out that if you've never really done a lot of coding, that some of the coding we'll do will be challenging, not because we're going to go super complex. In fact, we're not. But just because when you're learning a new skill, sometimes, it can take a little bit of mental work. We'll do the best we can to make it as easy to understand as possible for you. One key thing on that is when you see me writing code down, pay really close attention and write down exactly what I say. A reason for that is when you're writing code, little things like a misspelled word, a missing symbol, or even something's capitalized when it should be lowercase can result in code errors. We can all read, for example, we can read written text where people don't capitalize anything, and we can have whatever attitude we want about people that write with no caps, right? But we can figure out, quote unquote, what they meant. Computers can't do that. If they're expecting a capital letter A and they get a lowercase letter A, they don't register as actually being what they were supposed to get. And so they'll just stop and go, that's not what I expected. They don't really have that tone of voice. One other real big thing, if you happen to be joining us on a mobile device, it's going to be really rough to do the actual coding, but you can listen and learn a lot. So please do. Another real key thing is please put yourself in a distraction-free environment. You don't want to have the dog barking or the baby upset or whatever's going on while you're learning this stuff, because it takes some attention. And finally, if while we're coding, if you fall behind, don't worry about it. It's okay. Stick around, listen, and learn. And you will learn a lot. Ideally, you want to be able to get through the code, but if you don't make it, it's totally fine. You will get a full copy of the code at the end, by the way. Also, we are recording these. We record all these free classes, and they go up on YouTube. We'll get you links for that at the end of the class. All right, I think I know where everyone's joining us from. So, and obviously you guys can use chat. If you need anything, use chat. We're watching it. So, a basic agenda. We'll have a short explanation of the Tech Academy, who and what we are, and then we'll write code, which is awesome. We'll have a brief Q&A session. Although we do try to pick up some questions as we go along if you throw them into chat, right? We'll give you some information about our boot camps, and we're going to give you a free gift at the end, so please stick around. Whole class should take about an hour and a half, maybe less. So here's us, the Tech Academy. Who are we? Well, we provide coding boot camps. Coding boot camps, if you haven't heard of them, are intensive technology certification programs. They're designed to prepare people for a tech career really quick, like 3 to 6 months, get you into an entry-level position. And the reason they came about is they can do that in a short period of time, and they focus on modern practical skills so people can get a job right away, right? We've been doing it a very long time. We're around at the beginning of the boot camp era. In fact, we've been offering thorough, budget-friendly, flexible, trusted boot camps for over a decade, which we're really proud of. And our programs are really cost-effective. Also, they're all self-paced and online, and they're tailored for beginners, people who have no prior technical knowledge or coding knowledge. We have a lot of programs, more about that later on. They thoroughly cover in-demand skills for the tech industry. They're endorsed by really, really good online reviews, and they're designed to fit around your personal schedule. And we've tried to prepare you for your technology career with a really well-rounded toolkit. If you look at pricing, I don't know if you've ever examined this, but in America, at least, the average cost of boot camps is about $13,500. Ours are under the national average. And we even have programs that start as low as $5,300. And I always like to read our mission statement. Frequent attendees to our class could probably recite this verbatim with me. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field, and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. That's what we're trying to do. And we like to say that our product is you working in tech. About a month ago, we launched a new service, and we're really excited about it. It's called the Tech Academy Accelerator. And it's a monthly subscription program, really inexpensive, and it includes a few really cool things. One of the biggest ones that I personally love is that it has live weekly workshops with me. And I'll tell you more about that in a second. It's also got a library of over 100 educational videos and 100 self-paced online mini classes. What's unique about these workshops is that we do a really deep dive into often highly complex technical subjects involved in technology. And there's a lot of Q&A. We have open voice and chat throughout the workshops where people can interrupt and ask questions, and we go back and forth and go on tangents, learning really cool things. And we teach subjects that are suggested by the community. There's a good number of people in the community, and they have things they want to learn about. In fact, what we've been doing for the last couple of weeks is it's a blast where we're working at getting an application. If you happen to have an application that you want to feature, it's not for a company or anything. It's just something you built on the web. How do you publish and host a complex application? It involves a front end, some computer program somewhere on a server, and then a database. How do you get all that out on the internet and working well, communicating with each other? So that's what this Tech Academy Accelerator is. It's a lot of fun. And again, it's cheap. It's $9.99 a month. And you can even do a trial of it. You get your first 7 days free. Regina, can you drop a link into the chat for people that might be interested in that? Oh, let me grab co-host. There we go. That'll probably be a little bit easier for you, Regina. So she's going to drop a link in there. And if I really do recommend you sign up, attend the first workshop. And you're not going to be charged for that first week. Now, if you click on the link, they will ask you to put in credit card data, but we built the tech ourselves. It works pretty well. They're not going to charge you for that until that first week goes by. All right. So that's the Tech Academy Accelerator. And honestly, it really is fun. I'll tell you one key thing about it. If you're studying technology, you've probably seen like tutorial videos and that kind of thing. And unfortunately, because they're highly edited, they can make it look like everything goes really smooth when you're developing software. Nothing could be further from the truth. And so when we do these deep dives into complex technology subjects, you get to see me, and in fact, the group work through the inevitable barriers you're going to hit, the mistakes, figure it out, research it, try a few things, and boom, suddenly it works. And that's what technology is really like when you do it. It's not all pretty, right? So we show you how the sausage is made. It's another phrase for it. A lot of people find it really, like, it can be very educational to see what it's really like to make software. All right, so we're going to get started here in coding in a couple minutes, and I want to just cover a couple of basic definitions. Probably you have already an understanding of some of these words, but I just want to clarify them. So we're going to build programs. And a program is just a set of written instructions that you can enter into a computer that make it do things that you want it to. So instead of using someone else's program, you're going to jump into the driver's seat and you're going to make a computer program, right? And you do that using a programming language. It's a set of words and symbols and phrases. And these words and symbols and phrases, they mean specific things to a computer. They tell it exactly what to do. And there's a lot of programming languages we use to make programs. And finally, there's the verb coding. Coding means doing what we just talked about, entering in those instructions, entering in the instructions that make up a program. That's called coding. And those instructions, like you can call that code. Like, look at this section of code right here, is what you'd say. You could also say, look at this section of the program. And that would be fine too. All right. I do want to cover what JavaScript is. In fact, there's 3 different technologies I want to just make sure you're well oriented to, because they form the backbone of any kind of development involving the World Wide Web, right? Web development. The first one is JavaScript. It's really popular. Like, it's gotten tremendously popular over the last decade compared to where we were 10 years ago. And it was created a long time ago. It's been almost 30 years. Wow. Okay, I feel old. Originally, it was designed just to make web pages dynamic and able to be interacted with. For the original web pages, you couldn't interact with them at all. It was just text and images, and that was about it. It's like an online brochures is really what they were a lot of the time. And so really smart people developed this language, JavaScript, to make it so you could actually have, variable behavior in a web page and have it detect user actions and that kind of stuff. But beginning about 15 years ago, someone developed a really cool technology that lets you use JavaScript not just for the web, but to make any kind of program, which is cool. The next technology I want to tell you about is HTML. It stands for Hypertext Markup Language. Hypertext, by the way, is anything on a web page that links to somewhere else. Hyper meaning beyond, and originally it was only done with text. But yeah, anything on a web page, if you click on it, it takes you somewhere else. That's hypertext. Markup language just means a language that describes how to change the appearance of a web page, which text is bold, which is italic, that kind of thing. So that's HTML. So obviously you can see how that would be important in making anything related to the web. And finally, there's a technology called CSS. It stands for Cascading Style Sheets. A style sheet is just a little document that contains rules about how to style different things on a website. When should you use this color? When should you use that color? What things should be underlined? If someone's accessing from a mobile device, how do you resize the images? All these things, you want to set rules around them so that the people using your website have a good experience. And that's what a style sheet is. What cascading means is you can set it up so that one sheet, it's just a file. It's just a bunch of text. But you can set it up so that one sheet and the rules inside it can apply to whole sections of your website or even every page in your website. And that way, if you want to change something significant about the way your website looks or behaves, you can change it in one place and it affects everything. So if you have a large website, that's really valuable. So these three technologies, they're all about the web, right? Now, this is a JavaScript class. And so as the class name states, you're going to use JavaScript code in this class. We're not going to dive into HTML and CSS. You might see a little bit of it on the screen, but we're just going to concentrate on the JavaScript. All right. Now, if you've never attended one of my classes, I just want to pause for a moment and give you a very strongly worded opinion. You don't have to accept this at face value, but I have been teaching this subject for a very long time. In my opinion, the 5 things I'm going to teach you right now are some of the most valuable pieces of data you will ever learn in the area of programming. Not because they're super complex, but actually because they're very simple, and they should simplify the whole subject for you. There are only 5 elements that are used in creating any kind of program. From the most simple thing to huge giant programs like these big multiplayer, massive multiplayer online games and everything, right? There's just 5 elements. Now I'm going to present them to you and explain them briefly. And then later when we're coding, when we're writing JavaScript code, we're going to show you how to do each of these 5 elements in JavaScript. So what are these elements? Well, the first one is an entrance point. Any computer program needs to have a first instruction. You can kind of think of a program as just a list of things to do. You're entering into the computer and saying, well, first do this instruction and then do this one. Like first, ask the user for their name. Second, display it on the screen. Third, ask them what type of products they're interested in. Fourth, search the database for that kind of product. Fifth, display them on the screen, whatever, right? Well, you need a first instruction. You've got to tell the computer where your program lives, what to do if someone starts that program. If someone turns the program on, what's the first instruction? And this is valuable for a lot of reasons. But the simplest one I can explain to you is this. When you're trying to figure out what a program does, and you weren't the one that wrote the program, it can be a little challenging to follow along. And one of the most valuable things you can do is find that first instruction and just look at it, understand what it does, move to the second instruction and understand what it does, and third, and so on and so forth. And as you flow through, you'll really start to understand where the programmer's head was at, what this program that you're looking at is all about. So for that reason alone, it's really valuable to know where the first instruction is and to know that there really is one. So that's the first element of a computer program. The second one, if I can get my computer to actually behave, is variables. This is something that's inside your program, and it's just a way to keep track of data that can change while the computer's running. If you're building a game, obviously, like keeping track of a score by points, they get points for, like if we look at Tetris or whatever, right? Or these match 3 games. There's about 395 million match 3 games. I counted them all. So every single time someone matches 3, they get some points. You got to keep track of that. Well, clearly that number is going to change as the game goes on, right? So computer programs need a way to keep track of data that changes, which seems pretty obvious until you realize that 50, 60 years ago, when they were first creating programs, this construct of a variable didn't exist. They would build a program to handle one specific exact situation based on data that existed at that exact time. And what they found was you needed to make a new computer program every time you solved a different situation, which is really, really stupid. And so they developed this construct, which I'll explain in detail when we're writing JavaScript, of, well, how can you make a variable? Something will change as the program runs. So you got to have those if you want to have a useful program. The third element of any computer program is what we call control and branching mechanisms. You need to be able to control the flow of a program. Most programs have points in the program where there's 2 or more possible paths to take based on some data that can be analyzed by the computer. We call those paths branches. And we call the instructions to figure out which branch to take control instructions. So a computer program that doesn't have these is of extremely limited value. And so it's a key element of a computer program. And you're going to build some tonight. And finally, subprograms. Now this goes by a lot of names, but let's just look at the central concept. It says programs within programs. But to kind of help you understand a little bit about what that is and how it works, when people were learning this whole programming thing and really developing it from scratch, again, 60, 70 years ago, the following would happen very, very often. They would sketch out on paper what they wanted their program to do, right? And then they start entering instructions into a computer, one instruction at a time. And very often, they would find that there was a type of action that they needed to repeat many different times in a computer program. Some set, like a handful of instructions, that the same instruction got repeated over and over again at various points in the computer program. They went, well, wow, this is really foolish. Why am I retyping this each time? It's easy to make a mistake and not do it exactly the way I did it before. And, every time I re-examine my program and realize, oh, something about the way I do that handful of instructions needs to change, I've got to go back and change it every single place I put it in the program. Well, that's not really smart. So some bright person come up with the idea, well, why don't we take those set of instructions you're repeating over and over again and put them in a little container called a subprogram. Give that subprogram a name. And then anytime in your computer program you need that set of things to occur, just call on the subprogram, tell it to do its job, and let you know when it's done. In plain English, that's all a subprogram is, but they're really, really powerful. And without them, you have really, really poor computer programs that are very hard to manage and will drive your fellow programmers and you up a wall. And there's lots of other benefits that you'll learn over time, especially if you go through a boot camp, right? But that's what a subprogram is. And the last one is kind of surprising to some people. A key element of a computer program is an exit point, the end of the program. The main reason that this is important is your program needs a way to tell the computer that it lives on, hey, I'm done. I'm going away. I've finished everything. And again, I'm using very casual language to refer to these concepts, but it really is that simple. And the reason why that's important is that while your computer program is running, the underlying computer that it's on is doing a lot of work to help your computer program run. Not the least of which is that there's a bunch of places in the computer, in the actual physical box. I'm tapping my tower right now. There's a lot of devices in that machine that store data. And part of what happens when you start a computer program is the computer that the program is running on takes big sections of that data and walls them off and says, hey, these sections of that memory, that storage area, it takes big sections of the storage area and says, hey, these areas are walled off. Only this one computer program is allowed to access those so that no other program can come along and accidentally change the data in there. And now your program is working with data that's wrong. We don't want that to happen. I'm sure you can, get a picture of why that would be a bad thing. Well, when your computer program is done running, that protection is no longer needed, and the computer can free up that storage area, making a lot more available for other programs. So for that and a few other reasons, a key element of any program is an exit. So we're going to get into coding here in a second, but I just want to stress that part of the reason that these 5 things are so important is, again, any computer program you ever make or see of any level of complexity is only made up of these 5 things. You won't find anything else in it. So it's good to know these 5 things. Now, they don't get put into the program in this order necessarily, right? Numbers 1 and 5 happen to be in order, but variables, control and branching, subprograms, they get used all throughout a program. But the other reason this is super valuable, and you'll probably see a little bit of it tonight, is if you're trying to learn a new computer programming language, one of the smartest things you can do in my experience is to have a list of these 5 elements and just learn, how do I do these 5 things in this new language I'm learning? If that's your entrance point into learning that new language, you'll actually be learning the most important thing. How do I make the 5 elements of a computer program in this language? So it'll make it easier to pick up more and more languages as you advance in your technology career. So those are the 5 elements of a computer program. While I take a sip, does anybody have any questions about that you want to throw in chat? Welcome, Tom. I see KV Sai, welcome. Let me know where you're joining us from, by the way, if you just arrived in the last few minutes. Drop in the chat and let me know. I'm Erik Gross, I'm your instructor. Greensboro, North Carolina. Very cool, Tom. Glad you're here. That's a pretty state, man. All right, so we're going to get into actual coding, and we need a place to do our work. So you're going to do that in a thing called the code editor. Regina, if you could drop that link into chat, I appreciate it. Good. Everybody click on that. And what you should see is something like you'll see on the left over here. You'll see 2 different panes, 2 different like sections of the web page. There'll be some code already in there. Just ignore it. Don't worry about it. But that's what you should see. And what I really want to be able to have you set up is having me on your left and your code editor on the right. So in other words, on the right will be the actual browser tab you just opened. And on the left will be your Zoom meeting, because I'm going to share my code editor in a moment in Zoom. So go ahead and set that up right now. Sometimes you run into a hassle trying to get Zoom to cooperate. And I've found that if it won't resize and let you move it around on the screen, that if you click on the words Zoom meeting, this little menu pops up, click on restore, and it'll suddenly make the whole window smaller, and you can resize it and move it around. As for the browser, you can do the same thing, and you do it by, let's see in a second here. Over in the top right there, there's a little resizing thing. You just move it around and resize it. If you have any questions about that, let me know. All right, so let's get into coding. So first thing is, I'm going to show you the program in full. You're not going to write the whole thing right now. In fact, you're not going to write the whole thing tonight, because there's a fair bit of code here. It'll be way beyond the scope of what we can get done in an hour and a half. But you'll understand what's going on in the code, which is really cool. So in a minute here, I'm going to run the full game, and you'll see me play. And then, like I said, we're going to switch over, and you're going to learn each of these 5 elements, how to do them in JavaScript. And then we're going to review the code that makes up the game, and you'll see that your understanding of what's going on with it is probably much higher, which is really cool. All right. Let me switch over here. I've got my editor. And I think I can go ++ and make things a little more readable. There we go. If I go on the left here, don't follow along with anything yet. What we're looking at right here, I'll start at the top. Again, don't worry about what's going on here, except to know that anything in green is a comment, and does not cause the computer to do anything. It's just a comment to help you and others understand the code. But you can see there's a lot going on here. There's some of that HTML stuff I talked about, right? This is some CSS, that style sheet stuff. It controls, like, look at that. You can kind of even read this, that anything related to the score, because we're going to play Pong, right? The score is going to be aligned in the center. This is how big it's going to be. This is what color it's going to be, right? You may not understand all of this, but these are just rules about the styling you want to be applied. And now we get down to the actual code. One thing to know, remember how I said JavaScript was designed to help make web pages interactive, dynamic? Well, to accomplish that, they said, well, if you put JavaScript in between script and let's go way down, and end script, if you put some JavaScript code in there, your browser, like Chrome or whatever you use, will be able to run that JavaScript program. And so in between those two things, all of this is the JavaScript that is our program. You see some complex stuff going on in there. Like I said, by the end of the class, you'll be able to read through it and understand a lot more about what's going on with it. There's a fair bit here. Can you see how it might not be the smartest thing for us to spend the next 4 hours actually building this? But there it is. That's the program, right? If I run it, I need to go a lot smaller here to make this work. You can see the blue one is me. I'm moving it around by moving my mouse up and down. I think, right? No, I didn't do it. Okay, you lose. Play again. All right, so it's Pong. Okay, Pong is pretty straightforward. Now, what I don't like is I don't think the computer ever fails. It's not fair. All right, so let me go ahead and stop. Okay, so that's the game. Now let's get into actually building something in JavaScript. And again, we're going to look at these 5 different elements. So what I want you to do is I'm going to give you a little bit of code here. In fact, let me refresh this. There we go. Okay. So this is what you all should see right now. If you don't see what I have right here, then I need you to refresh the page at the top of the browser and get back to here. Okay. The reason for it is, remember I told you that all the JavaScript goes in between these 2 script things. So I want you to delete what's in there. Just get rid of it, because that's where we're going to write our code. The first bit of code I want you to write, in just a minute, and I'll open it up. All right. So I just want to have you be able to make a little pop-up box, they call it an alert, appear on the web page. So one of the instructions that is in the JavaScript language is the instruction alert. And so I want you to just type along, and then we'll explain what's going on. So give me a lowercase A-L-E-R-T, alert. And don't hit space. Then give me an open and close parentheses. And then, this part's important, move your cursor back inside those 2 parentheses. And I'll explain. Alert is an instruction in JavaScript. And what it does is it makes an alert pop up. You saw an alert in the game there. It said, sorry, you lose, or whatever it said. You want to play again? That's an alert. You all have seen them on lots of different websites, right? The way this particular instruction works is it needs some information in order to do its job. It needs you to give the text that should appear in the alert box. And the way you give it information, and you'll see this in a lot of different languages, especially JavaScript, the way you give it the information is you put that information inside of an open and closed parentheses. The JavaScript language works that way. So let's put something in there that just says, hello. But you'll notice I put it inside of double quotes. I'll explain that in a second. Just go ahead and catch up to where I am. Clearly, we know that this pop-up, this alert, is meant to display text of some sort. And so we're going to give it text. In JavaScript, again, in most languages, if you're going to give it text, it needs to be inside of 2 double quotes. Don't use that single quote. It's just to the left of the Enter key. Hit Shift and give me the double quotes. And then go to the very end and give me a semicolon. In JavaScript, the semicolon says to the computer, the current instruction is done. Please perform that instruction. And now you can run it. Hello. All right, good, excellent. By the way, I'm going to make a tiny change here the way I've done this. I just realized there's something we can do to make this a little more easy to follow along. I want you to go back in and right before the hello, put 1 colon and then a space. I'm only doing that because we're going to do a lot of different alerts during this game. And I want you to see which ones appear in which order. That's all. So I'm going to run it again. You should say 1, hello. Good. All right, pretty simple. You have to click OK to make it stop error. So we have our first instruction. And by the way, in general, in JavaScript, whatever, you can find the first instruction in the very first file in your program, right at the top. A lot of languages are that way. But in some languages, you can specify somewhere else for the first instruction to be. We're not going to get into that level of complexity tonight. All right, so we have that 1 instruction. Well, let's do it again. Let's do another alert that says hello again. ILERT. Remember, you got your open close parentheses, and I'm just trying to teach you good habits. Anytime you have an open parentheses, immediately type the close parentheses and then go back in between them. I recommend doing that because if you forget that last parentheses, it can lead into a lot of problems in your code, and it's pretty easy to forget it sometimes. So I've taken years ago to just training myself to always type the second one right after the first one, and then go back in between. Let's say hello again. So again, you need double quotes. Again, I like to type them both and then go back in between them. That way I don't forget the second double quote. And now we're going to do hello again, but let's put the 2 space dash, or sorry, 2 colon, and let's say hello again. Like that. And you go to the very end and give me that semicolon again. Run it. And you should see, hey, the first instruction is the one we thought. It's right at the top. Click OK. Hey, there's that second instruction. All right, good. That's not complex. Now, let's get into a little more complexity. We talked about using variables. One of the things that we care about in this game is what's the position of the ball. The ball is moving around the screen, right? Now, those of you who are kind of math nerds know that to actually properly indicate the position of the ball on the screen, you'd have to have 2 numbers, an x-axis number and a y-axis number. X is horizontal and y is vertical. We're not going to get into that kind of complexity right now because we're not trying to teach super complex stuff. We're just trying to teach how do you make variables and how do you use them. So we're going to make a variable for the position of the ball. We're just going to make it equal to a number. That's all. So in JavaScript, one of the more common ways to make a variable, and there are a few, we're not going to get into all of that, but one of the most common ones is to use the JavaScript instruction var, var. So type that. You'll notice it turned blue. That's just this code editor we're using, being really friendly and making it easy to understand what you're reading. So there's a var, and you do hit a space after this, because the next thing you need to do, you have to give a name for your variable. I'm going to pause for a moment and kind of explain the basic concept. Now, this is an analogy. It's not precisely what goes on inside the computer, but it's a great analogy. What you're doing right now when you create a variable is you're making a bucket somewhere inside the computer, and you can put information or data inside that bucket. So you need 2 different things. You need a way to identify an individual bucket, and then you need to put data or a value inside it. Well, what we're going to do right now is first give an identifier to the bucket. Like, think of like we would write this on the side of the bucket. And it would have to be unique, so we couldn't confuse that bucket with any other buckets. That's the name of the variable. We're going to name this variable ball position. I want you to type lowercase b-a-l-l, and then an uppercase p, but then back to lowercase o-s-i-t-i-o-n. That's the name of our variable. You can hit space. So we have, like I said, it's an analogy, but it's accurate. We've created a bucket inside this data storage part of the computer called ball position. What we did in technical terms is we declared a variable. We just created it and gave it a name. But now we need to put a value in it. We need to put some data inside that bucket. You do that in JavaScript by doing an equals sign. And what happens is that anything on the right-hand side of this equals sign is the information that gets stored inside the variable. So we're just going to say the position is 100. Now, again, a real position would have two different numbers, like 100, 150. We're not going to make it complex. It gives some difficulty in illustrating what we're trying to learn tonight. But you'll see that inside the real program. So give me a semicolon just to say, hey, we're done. And now we have a ball position. We need to do something with it. Well, let's just print it to the screen. So I want you to give me an alert again. Make sure you do your open and close parentheses. And make sure you give me double quotes. And go right in between inside those double quotes. What we're going to say is the ball position is, and then we'll use our variable. So we can type the ball position is colon space. Now, let's pause for a moment here. Right now, because we are looking at the code, we all happen to know the ball position is 100. The wrong thing to do would be to type in 100 right here. Because again, that means that every single time we hit this instruction, we're going to put 100. But what if we as programmers made that into 200? That is not true anymore. Let's go back to 100. What we're going to do instead, let's erase that 100 if you followed along and typed it. We're only going to print that text, and immediately after it, still inside the alert box, we're going to print what's inside the bucket. We're going to grab the variable, reach inside it, and get the value stored in the variable. You do that really easily. Move your cursor to right after the double quotes. We're still inside the parentheses. And that's an important point. Remember, inside these parentheses is all of the information we're going to give to the alert instruction. If it's outside of the parentheses, it's not going into the alert instruction. So stay inside. And what we're going to do is we're going to add on more text data. But we're going to get it from our variable. Well, in JavaScript, if you want to take one chunk of text and have it connected to another chunk of text, you use a symbol like this. Give me a space, and then a plus symbol, and another space. That instruction means please concatenate. Isn't that a fancy word? Concatenate two pieces of text. It just means stick them together. That's all concatenate is. So, again, the text we want is stored inside the variable, so let's print the name of the variable, ball position. Make sure you spell it exactly the way you spelled it when you declared the variable. And then at the end of that, you can give me a semicolon. If you follow along, you can click run. The first instruction, hello. Second one, hello again. And then the ball position is 100. Just again, to make it easier, let's do our 3 ball position is. So there's 1, 2, 3. You wouldn't do that in a real program. I just want it to be easy for you to follow along with where things are in the program. All right, so why is this valuable? Well, it's valuable because the ball position is going to change from every few milliseconds, right? So let's simulate in our little program we're making here the idea that the ball position changed. Go to the very end of that last instruction we made, hit enter, and change your ball position. Since we've already declared or created our variable called ball position, we don't use the variable word anymore. The variable word is only used when you initially make the variable. Now we can just call the variable and give it a new value. So we do ball position. And then assign it a different value. Let's say at 110. It moved 10 pixels or whatever. Pixels are the individual dots on the screen. So let's do a semicolon there. Now, don't run it. Don't run it. Don't run it. In chat, I want you to predict what the final prompt will say when it appears on the screen. The last prompt, what's it going to say? Drop in the chat what you think that final prompt or alert is going to say. Excellent. Van Hensel got it right. Third prompt is still going to say 100. Nathan said 100. Ball position is 100. You're all absolutely right. But didn't we change the value? Well, yeah, we did. But at the time that we ran this alert command or instruction, the value was still 100. And I just want to pause here because it's a really important kind of lesson. One of the chief things you can work on when you're trying to break into technology and become a coder, programmer, an engineer, whatever you want to call yourself, is developing the ability to think like an engineer, to think like a programmer. But one of the primary ways you can start to do that is to learn to think methodically with one instruction at a time, and also to picture in your mind what's the exact state of the computer at any point in the program. Because again, if we look at this exact instruction, what we have to think with is, what's the condition of everything inside of my program at the exact moment I tell the computer to run this instruction? Which probably seems obvious to you. But I just want to point out that being able to follow along, I'm glad you all got the right answer, because it shows you can follow along with the step-by-step instructions and think about the state of a computer program at any point in time. Well, we know we changed it. I want you all to type this out yourself. Give me another alert. Give me another alert that shows the new pole position. I want you to type out exactly what you think it should be. And when you're done, if you think it's right, drop it into chat. How do we make an alert that shows the current ball position? You get it done, you think it's right, drop it into chat. Even if you're not sure. Van, you got the right approach. Go ahead and do it, and then let me see what you came up with. Nathan, I think you nailed it. I think Nathan has the right answer. What I'm going to do is I'm just going to copy his answer and throw it in here and run it. There's number 1, hello. That's from right down here. There's number 2, hello again. It's from right below it. There's number 3, right after we declared the variable. Oh, look, there's number 4, and it has a different value. Again, very simple. But this is important stuff to learn. These are the building blocks of making any program. All right, so that was correct. If you need to catch up, I'll give you a second. Good job, Robert. Good job, Nathan. Van Hensel, you had exactly the right approach. How did that go? Did you get it right? Awesome. Good job. All right, so we've got an entrance point. We've got variables. Now let's cover control and branching. Let's just think about the idea. What do we want to do if there's a collision? Like if the paddle and the ball collide. Well, the paddle can move. So we need another variable that keeps track of the position of the paddle. So the next thing I want you to do is I want you to make a variable for our paddle position. And we'll use that var. Everybody says var, even though it's for the word variable. Give me a var, and we'll do paddle position. So like that. Now that's declaring the variable. We give it a name. It comes into existence. We have an empty bucket with a name on it. But now we need to put some data in it. So give me an equal. And let's say it's at 199. That's the position. Good. I got my semicolon to tell the computer I'm done with that instruction. Now that we have two different pieces of data, we can do some control and branching. Because I'm sure you can see that over and over again, as this Pong game runs, we have to check whether or not the player successfully put their paddle to where the ball on the paddle would hit. There's a collision. So we're going to check if there's a collision. The way you'll do that is with a control instruction. I mentioned there's two things here. There's control to decide which of two or more branches to take. And then there's branches, the actual instructions that will be performed, depending upon what the control instruction does. One of the main control instructions in this and most language is if. I mean, if, notice it turned blue. That means it's a JavaScript instruction. Now, if, don't hit space afterwards because I need to explain something. Actually, give me an open and close parentheses like that. Let's just talk about this for a second. Because again, this is another key aspect of computer programming. This control instruction, if, its only job is to tell whether or not what's inside the parentheses is true. It's really its job. If something's true, do one thing. If it's not, do another thing. That's just basic. Again, described in plain English. That's what its job is. So you need to give it some information that, when I say it, I mean the if instruction. You need to give the if instruction some information that is capable of being analyzed by the program and will be either true or false. And that's it. Now, there's a lot more nuance to that you'll learn when you do full, computer programming training. There's other possibilities of information you can give to the if control instruction. But the basic concept still works. We need to give it some information which can be either true or false. And the information we want to give it right now is the ball position and the paddle position identical? If they're equal, hey, we have a collision. Now, yes, it's a little more complex than that in the real program, but we're just trying to illustrate the point. So all you would do is give the names of the variables, but you use a special symbol in between them that says, please check whether or not these two things are equal. So let's build it like this. Let's do the two variables. First, let's type ball position. Make sure you spell it the same way you did before. And then let's do paddle position. Make sure you spell it exactly right. Now do this. Go back right after ball position. And now in between these two, we're going to give a special symbol that tells the computer, please compare these two things and see whether or not they're identical. So give me a space and then two equal signs. That is the special instruction in JavaScript to tell whether or not two things are equal. And obviously it reads almost like English. But here's another learning moment. When you're glancing through code really quickly, it's really easy to see a single equals, a doubles equals, and think you're looking at the same thing. They're not the same thing at all. Like they're 1,000 miles apart. The single one is used to assign a value to a variable. That's what the single equals is. The double equals is used to compare the equality of two different pieces of data. They look remarkably similar, and they are absolutely not similar at all. So what we have right now, and this part's critical, is we have a control instruction. It's complete. We've used the if, a control instruction, and we've given it data that the computer is capable of evaluating to see whether or not it's true. The next thing you need to do is to provide the branch. What instruction or instructions need to be performed if this condition is true? In JavaScript, you put those branches inside of two curly brackets. So give me a space and do an opening curly bracket. You'll find it probably on the second to the top row. It looks like that. It's above the square bracket. And then hit enter twice. And give me the closed curly bracket, like that. And then this part's important. Move back up in between them. Those brackets curtain off or put a fence around the instructions that you want to occur if the condition is true. And they'll only be done if the condition is true. So what do we want to do? Well, let's make it really simple. We'll just pop up an alert that says collision. In the actual game, other things would happen, but we're just illustrating the concepts here. So this next part's pretty important. I want you to hit space twice. It doesn't do anything to the computer. It doesn't make it perform any instruction. It's just for readability. It makes the instructions inside these curly braces or brackets easier to read. So all we're going to do is do an alert that says collision. You should be able to do this by yourself now. Alert. Collision without an H. Spelled correctly. There we go. Now, once everybody's caught up, I have another super important question. Don't run it, don't run it, don't run it, don't run it. Yeah, you're exactly right, Robert. Here's the question, and this part, it's not a trick question, but it's a question designed to test your attention to detail. And this may take you a full minute to type out. I want you to type out into chat, send into chat to me, the exact information that will print on the right-hand side when we press run. What exactly will print on the right-hand side when I click run here in a moment? Put your guesses into chat. Nope. No one's gotten it right so far. I'm not trying to be a real trickster here. I want you to look on the right-hand side. On the right-hand side right now, it says My Heading. Play around with the code and click on the run button to view the result. But when I click run, something else is going to appear on the right-hand side. What's going to be there on the right-hand side? Oh, I kept saying right-hand side. I apologize. I'm asking this the wrong question. I did mess this up. Wow. Okay. So there were some right answers here. So let me ask it a little more precisely. What is the final alert that pops up going to say? What does the final alert say that pops up? I apologize for that. Tom, that's not right. Nathan got it right. He said, instead of Van Hensel, says 4, the ball position is 110. Let's run it. 1, hello. 2, hello again. 3, the ball position is 100. 4, the ball position is 110. I'll click it one more time. That was, in fact, the last thing to pop up on the screen. Ah, Tom, you caught it. Good job, exactly. Why did it not print collision? Because at the time we evaluated this condition, ball position was 110 and paddle position was 199. That's why they're not equal. They ain't equal. Nathan, you're exactly right. Absolutely. That is redneck programming right there. Them two ain't equal. So let's make them equal. Go here and make paddle position 110. And now run it. There's hello. We'll get there, Robert. There's hello again. Ball position is 100. Ball position is 110. Oh, collision. Okay. All right, good. That worked. All right. So Robert's absolutely right. Robert says we need something else here, because here's my question is, we've told the computer what to do if these two things are equal. But we haven't told it what to do if they aren't equal. Sorry, if they ain't equal. All right, Nathan. A cowboy hat on a smiley face. You're awesome. So there's a special instruction here in JavaScript that lets you put what to do if they're not equal. It's called the else statement. So go down to the very bottom here after this curly brace, give me a space, and then type else, E-L-S-E. Notice it turns blue because it's a JavaScript instruction. By the way, it's only changing colors because this code editor provided by W3 Schools changes the color to make your code easier to read. We could do all of this in a little text editor where everything was all black letters on white background. Just makes it easier for you to read. All right, so I have an else. And following that, we need, oh, by the way, let me explain a term. When I highlight this right here inside the curly brackets, that's called a code block. It's a section of code, a block of code. So we need a code block, a set of instructions, to do if ball position is not equal to paddle position. So go after the else, give me a space, and give me more of those curly braces like that. The open curly brace, hit enter twice, give me a closed curly brace, and go back up in between them. So now we have a place to put the code block for what to do if ball position is not equal to paddle position. So hit space twice just for readability. And now I want you to make an alert that says missed. A-L-E-R-T. Missed. Now pay close attention. It's easy to make little typos with your double quotes and your parentheses and everything here. Well, we know that we're going to get collision because we did that before. So I also want you to go up and make the paddle position 109. Ah, we just missed it. Oh, now run it. There's one hello, two hello again, 3, 4, and now it should say missed. If you didn't get that, make sure you're typing everything right in here exactly correctly. All right. In chat, give me a 1 if your code worked correctly. Give me a 2 if it did not work correctly. One, 1, 1. All right, good. All right, so we now have control and branching statements. And again, to clarify, the if is a control statement. You give it a condition that the computer can evaluate. You then provide branches. Here's a branch for if the condition is true. Here's a branch for if the condition is false. Oh no, Robert says, I just lost everything. Robert, I am going to copy all of my code and I'm going to drop it into chat right there so you can get caught up. All right, so we're on to the final thing we're going to talk about, which is in terms of coding here. Subprograms, repeatable chunks of code. So as I mentioned earlier, we're probably going to, as you know, this computer program runs, check over and over and over and over again whether or not there's a collision. We're probably going to check for that every few milliseconds. So let's write a subprogram that we can use over and over and over again to see whether or not there's a collision. Because I tell you what, I don't want to wait 3 milliseconds and then do all 4 of these 5 lines, type these 5 lines. and then wait a few milliseconds, and then do these 5 lines. I don't want to type that over and over again. I'd be typing it hundreds of times. That's silly. So we need to make a subprogram for it. Well, go to the bottom here and hit enter. And in JavaScript, subprograms, repeatable chunks of code, are called functions. To make a function, you first type the word function. So type it out all lowercase and give me a space. Now, what JavaScript expects after you type the word function is, thank you, could you please give me the name of the function? Because remember, we want to be able to call on this thing to run whenever we need it. And that's actually the verb we use in computer programming is you call a function. Well, it has to have an identifier, a name. Let's give it a name. We're going to call it check collision. Now, I capitalized this, but you don't have to. And you can call it whatever you want. We can call it FUBAR. You can call it Walt Disney, whatever you want. All right. Oh, Robert, I messed that up. Let me see if I can do this. All right, you should have gotten it, Robert. Please give me a 1 in chat if you got it. Thank you, awesome. So we're gonna make a function, it's called check collision. And again, I like to capitalize my functions. You don't have to at all. There's no law about it. No one's gonna be upset if you make it lowercase. I'm not gonna be upset if you make it lowercase right now. But you better spell it the exact same way when you call the function later on. So I shouldn't have put a space after check collision, and I'll explain why. One of the things about subprograms, again, I'm going to keep on using the word function because in JavaScript we call them functions. It's still the subprogram concept. Lots of languages use different terms. There's subprogram, subroutine, program, function, method, a bunch of different terms. So one of the things about functions is that very often you need to give them some information in order to do their job. And that's certainly true here. Every time we want to check whether it's a collision, we better give it the current position of the ball and the current position of the paddle. Well, the way you do this, passing in information, is you put it inside of open close parentheses. So give me an open close parentheses right after the word check collision, no space between them. And then go back inside there with your cursor. And now we need to give it 2 pieces of information. These are called parameters, by the way. The information passed in to the function is called a parameter. And all you want is the 2 variables separated by a comma. So let's do ball position and paddle position. Comma, space, paddle position. Make sure you spell it exactly the way we did before. I can't drag this, can I? Oh well. Make it a tiny bit smaller just so you can see all on one line. So this is what you should have right now. We have told JavaScript we're creating a function. We've given a name for our function, and we've given parameters for the function, information that will be passed into the function whenever we ask it to be done. All right, now, just thought of another way to make it really easy for everyone to follow along. I want you to go back up here inside of ball position, this if. I want you to go in here, and since no matter which thing happens, it's going to be the 5th alert to pop up, I want you to put a 5 colon on both of these. All right, so let's go back down to the end here. So we have told JavaScript we're making a function, we've given the function a name, and we've defined the parameters we're going to give it. Now we need to tell it what to do when we call on it. We need to give it a code block, a block of code to be performed. So give me a space afterwards, and then you know it, open curly brace, hit enter a couple times, close curly brace, go back up in between, and hit space twice. And here's where we're going to give it all the instructions. Now, this should not be a shock to you. We already know what to put in here. We know how to check whether or not there's a collision. It's right here. So you could just copy all this, which is what I'm going to do. I recommend you do, because we know what it says. Go in here and just paste it all. Now, when you do that, it makes it funky, hard to read. So don't do anything else yet. Make sure you're caught up to where I am. Then I'm going to show you a nifty little trick to make it a little easier to read. So you should have taken this entire chunk right here. If, alert, brace, alert, brace. Take all that, copy it, and put it in between this brace and this brace. Now, if you've done that, watch what happens to make it a little bit easier to read. Doesn't change the way the program works. Just makes it easier to read. I want you to select everything you just pasted in. Nothing else, not the bottom curly bracket at all. And once you have it selected, hit the tab button once and notice it moves it over for us. Isn't that nice? And now look at how much easier that is to read. Here is our code block for our function. Now, I don't want 5 here. This should be the 6th thing that comes up. All right, now, if you're all caught up, I have another really important question. What's going to be in the last alert to appear when I click run? Don't run the program and cheat. Put into chat what you think the final alert will say before the program's over. Van, it's a good guess, but it's wrong. Nathan, that's right. Tom, that's right. Now, Nathan thought, sorry, if you thought it was going to be 6 missed, I want to explain why. Because you're not foolish to think so. The clues to why it's not going to be that way were dropped here and there, but I never explicitly explained it. So I want to run this. I want to prove this. There's 1, 2, 3, 4, 5, and then that's it. Now, some of you already follow this. I'm going to explain it. The reason that we didn't get to here is because this whole section, look at what I've just highlighted. This function, that's good, man. It's a description of potential behavior. That sounds all nerdy and fancy, but it really is the truth. It's a description of some work your computer program could do, but you haven't told it to do it yet. All you've said is, hey, if I ever ask you to, here's what you're supposed to do. But you haven't asked it to do the work. You've just created this function called check collision. You've created potential behavior. And just thinking that way can make this whole function or subprogram or method thing a lot easier to work with. And we'll prove it by actually requesting that that function do its job. So go to the bottom and hit enter again. And now we want to ask check collision to do its job. You do that by just typing out the name of the function. Make sure you spell it exactly right. And in parentheses, end parentheses, just to be smart and go back in between. In the parentheses, give it the data it needs. Remember when we declared or created the function, we said, here's the information it needs. Here's its parameters. We need that. So let's put that in there. Let's do ball position, comma space, paddle position. And then do a semicolon at the end of that bad boy. And now run it. And you get 1, 2, 3, 4, 5, and 6. Because we actually called the function. Now, there's a lot more we could dive into about how all this stuff works and everything. But I just want to point out that we could immediately follow this, say, well, the ball moved. And now it is, in fact, equal to 109. So everyone put into chat what they think the final alert will say. Put in the chat, when I run this, what's the final alert going to say? Six missed, you're exactly right. Except that you're not. 1 hello, 2 hello again, 3 ball position is 100, 4 ball position is 10, 5 missed, 6 missed. Oh, you were right. What did I do wrong? Oh, duh. I didn't call it. I fell for my same trick. So let's call it. Call the check collision. Again, and pass in ball position and paddle position. And now run it. Y'all were right. I need more coffee. And now it should say that we have a collision. There it is. Collision. Yay. Awesome. So that's really the 5 fundamental elements of any computer program implemented in JavaScript. Now let's look at the actual program. I'm going to give you all the program. So, Regina, can you drop the link to the program in here in chat? You'll get the same file that you see on the screen. All right, grab the contents of that file, like do a Control A, Control C, or if you're on a Mac, Command A, Command C. Whatever you do, make sure you copy every single character. If you're dragging your mouse, don't miss anything. And then go back here and go inside here, do Control A to select all of it, Control V. You want to fully replace all the code we just spent all that time working on. Wipe it out and put in the new code. And then, all right, guys, I want you all to take a moment here and just play the game. I'm going to run the game. Oh, I missed. Oh, man, I'm not doing very well at this. This was the first video game I ever had when it first came out in 1979. Shut up, I'm old. All right, okay. Do it again. Come on, can I do it? Yeah, there we go. All right, I'm going to get to 40 and then I'll stop. Okay, awesome. All right. Cancel. So everyone stop playing if you're playing. And I just want to take you on a brief tour through this code. Again, you now have access to this code and you can muck around with the game and have fun. I want to point out, one, where the code actually begins. Because again, all this stuff is HTML and a bunch of style information. This is CSS stuff right here, cascading style sheets. That's not our code. Our code begins right here inside of script. And so you notice it's doing things like, these are comments, setting up the game. The canvas is the playing area. It's loading up our logo in the middle. So you can see the stuff it's doing, right? It's got variables. Constant is another type of variable in JavaScript. But you can see it's got the name of the variable and then the assignment instruction and then what we assign it to. Again, there's a lot more complexity here. If you went through one of our boot camps, you'd be able to read every single line here and understand all of it. But the basic concepts are there. We're setting up a bunch of stuff. And then we get down here and we have a bunch of different functions. Draw a rectangle, draw a circle, draw the logo. There's some functions. Okay, good. You can see some of the functions take parameters. X and Y, width and height. Some of them don't take any functions. Draw a logo, don't take any parameters. There's another function, draw the score. That goes down here, right? Another function, move the paddle. And here is what we built, a very simplified version of. It took in the ball position, it took in the paddle position. And right here, this complex thing is whether or not there's a collision. It gives back a value of true or false. If all of this is true, it means there's a collision. If it is false, it means there wasn't a collision. So you should be able to read through a lot of this program and actually follow a little bit of what's going on. Now, so far we've just defined a bunch of functions, though. We need to play the game. And we do that by running game loop. This right here runs the game loop function, which just updates and renders over and over again. If we haven't paused the game, we update and render over and over and over and over again. So that's how the game works. Okay. All right. Next. We got time for one question. Anybody have anything to drop in chat? If not, we'll move on to our next steps. All right. I'll continue to watch chat. If you think of something, drop it in there. Let's talk about the school. Oh, Robert, that's beyond the scope of what we can teach right now. I want you to jump back into the accelerator as soon as you can, and we'll go over the nuances on that. Because there are differences, but it would be way beyond the scope of what we can explain here. It's a good question, though. Okay, good. So these boot camps we were talking about earlier, right? And by the way, please stick around for your free gift. We'll be able to get you. I think you'll like it a lot, actually. It'll really add on to what you learned tonight in a very significant way. So we have 12 online boot camps. And as you can see, if you're looking at these logos, they cover a wide range of technology subjects, like from AI, which is really popular right now, to computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. And we have more certification programs than any other coding boot camp on earth, which we're pretty proud of, right? And I want to talk about these boot camps because they're not like training you've done before. I'm going to point something out. Most of our training or educational experience that almost all of us received is very much oriented to rote memorization, being able to memorize data and pass tests that show that you can remember data. It's not true always, but it's very, very common. We all experienced it for years, right? Have you ever experienced someone who can pass a lot of tests, but you'd never, ever want them to do any work for you? We saw that in the Navy. I can tell you stories about that. But on the other hand, you have people who don't have any real strong formal education that are brilliant in terms of getting work done. The two aren't connected. The reason I say that is this. Our boot camps are self-paced. Not everyone goes through them at the exact same pace, which is not what you're used to in traditional education. We do it for a reason. And we can do it while still providing every student with instructor support. We also can make we make our boot camps flexible. You can set your own schedule. Try doing that in school. You can set your own schedule and you can start any day. You can enroll 365 days a year. And it's great content. It's well-rounded. and it's in depth. It's also affordable. Like I said earlier, our programs are priced under the national average. And this part is really important. All of our programs include training both in job placement, like how do you go about getting a job in tech, and they also include job placement assistance. So you're not left on your own. But most importantly, our programs are designed for absolute beginners. No prior technology knowledge or experience is required. So you don't have to be a nerd to get through these programs, which is pretty valuable. We consistently land on every major best coding bootcamp list out there. There are organizations that are very thorough in the data they collect, and they always put us towards the top of the list, if not the top, which is awesome. Our average review rating across all the major bootcamp review websites, and of course Facebook and Google, is 4.8 out of 5 stars. And it's based on student feedback and graduate feedback, which is awesome. So I'm assuming that if you're on the call, you've got some interest in maybe working in tech. I just want to answer a bit of a question about why would you consider that? Well, it has great work-life balance. I can count on one hand the number of times I've ever had to pull like a 60 or 70 hour week in the last 15 years. It just doesn't happen. And you can get remote work a lot more easily now, especially post-COVID, than you could even before. Also, it's a very creative industry. It's really dynamic. You work with a lot of different people to make software. To make good software products, you have to do collaboration and communication and get very creative and get really proud of what you did, right? It's also a very stable industry. The jobs aren't going away, baby. It's awesome. I have a lot of information I can give you about that, but it's a stable industry that pays well. And if you continue to learn and apply yourself, there's regular increases in pay. And I want to stress this. There are very few fields that you can go into in modern society that can earn a lot of money that don't require massive amounts of education to get into. There's very few out there anymore. Technology is still one of them, which is fantastic. That said, there are barriers to doing a boot camp. I'm not going to lie, right? Tuition is one of them. It costs thousands of dollars to do a boot camp. Now, we've attempted to help make that easier to confront and handle by providing multiple financing options, including a big upfront discount. Also, monthly payment options. In fact, we have a tuition option for everyone, no matter what your financial condition. But the more important thing to think about, in my opinion, about like the cost of doing a boot camp, is that truly it's an investment in yourself. You are giving yourself a set of skills that is going to be in demand for the foreseeable future and which pays well, and where you can start earning money within months, which is pretty cool. It does take time though. You have a lot to learn to be able to be a well-rounded entry-level software developer. Thank you, Robert. Robert says, best decision I ever made. He's one of our graduates. But again, it does take time. Now, there's various approaches in the bootcamp industry about how do you solve that, right? One of them is that require in-person attendance. So you're there Monday through Friday, 9 to 5, just like, that's rough to do. All of our programs are online, so you don't have to come into a campus, and you choose your own study schedule. Yes, you have to do a certain minimum number of hours every week, or you're just not going to get through the program. But if you're serious about breaking into tech, you've probably been able to carve out at least 20 hours a week or whatever, right? And because you can do part-time study, yeah, we recommend full-time, but you can do part-time, and that means you can still hold down a job, say, or if you're also going to school. We have a lot of college students that actually go through our program, right? You can do that simultaneously, which is cool. And the last thing is a kind of a barrier to getting into boot camps. You have to have some technical interest or ability. But I caution you here, if you felt like maybe you don't have that technical ability, it might not be the truth. Because the fact is that some technology education materials are too hard, and it's not you that's the problem. The fact is that a lot of educators assume too much prior knowledge on the part of the student. They assume you know things because they've forgotten what it's like to be new to the subject. I made that mistake when we started the Tech Academy. About 2 months in, my co-founder, Jack, was reading through some curriculum I made and went, Erik, do you think that everyone already knows HTML and CSS? I went, yeah, don't they? It's like, no, Erik. And then he called me a bad word. He says, no, they don't get taught that. I went, oh, I did it. I assumed too much prior knowledge. And so we fixed that immediately, and we've kept that philosophy in all the way through. So the fact is, you don't have to be a nerd with a bunch of existing knowledge already to get through our programs. So if any of this makes sense to you, I have a question. Are you like working a dead-end job? Like there's an income ceiling you know you'll never get past? And even if you reach the top of your profession, it's still not relatively high paying? Or maybe you're unemployed and you need a career. Is working from home important to you? Do you want more time with your loved ones? The whole point is it time for a career change for you? And if it is, we're the solution. We're career change experts at the Tech Academy. That bridge logo there is for a reason. We are the route into technology for everyone. Any reasonably bright, kind person who can read, write, and do basic math can make it in technology. We know that because we have a decade of experience now breaking people into tech. And they make good money. Most of our graduates, on average, make $30 an hour in their first job. That's $60,000 a year. I want to point out, by the way, that the average wage of a college graduate in their first role is $55,000 a year. And it took them 4 years and tens or hundreds of thousands of dollars. And that's their average wage. Yes, they can go deeper into certain subjects. I'd rather make money right away and then keep learning. And we know this is true because we have over 1,000 graduates working in tech everywhere. Small businesses, medium businesses, the big companies like Nike and Uber, Epic Games, Facebook, Disney. We've got people working at all of them. So as a reminder, we have open enrollment. You can start anytime. And I encourage you to enroll now. This program will change your life. If you want to do that, here's how. There's a link. Regina will drop that in. There it goes. And when you click on that, you're taken to a really simple login form, or a really simple application form. And then after that, it's just a series of steps to find out about the Tech Academy. So you can make an informed decision. There's videos and articles. There's even like an optional step. You can book a call with our admissions staff and talk to them. They're the people that got thousands of people into tech, so they kind of can help you sort your questions out. So please fill out the form now. I'll wait a minute, and then we're going to get to your free gift. By the way, if you click on that and it takes you to a login screen instead, it just means you already have an account with us, and you should put in your username and password. You can see instructions on that on the slide I'm displaying. All right, so a couple more quick notes. You can earn a referral commission for sending interested parties our way. If there's someone you really think this might be a good fit for, first of all, get them to one of our free classes, absolutely. But hedge your bets. Give us their name and contact information, because if they enroll, we will send you a 5% check immediately for whatever they paid in tuition, which is pretty cool. And in a moment, we're going to give you an email address to use to get a hold of us, and you can just send that information in. I want to cover our books and our dictionary. We have 7 different publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, the Technology Basics Dictionary, and the Project Management Handbook. Also, we have You Are Not Stupid, which is an amazing book. The first course on all of our boot camps is called the Computer Basics course. It basically removes all mystery from computers and every aspect of technology. Our students love it. You Are Not Stupid is essentially that book in written form with a lot more added to it, including a history of technology that shows how we arrived where we are today. It deepens your understanding of tech and computers really, really well. I firmly believe everyone should read the book. So, the free gift. Well, we did the JavaScript class tonight, so we are going to give you a free JavaScript book. Look, this book is great. Jack and I put a lot of work into this. It's imbued with everything we've learned from getting thousands of people through our programs and into tech. You'll learn a lot more about those 5 fundamental elements of any computer program. You'll learn a lot more about JavaScript, and it's yours for free. We'll send you a nice physical copy. It's US only, and all you have to do is, if you look in chat, you'll see an email address, books@learncodinganywhere.com. Email us at that email address with your mailing address and your name, and we'll send you a copy. No questions asked. This is also an opportunity to send me more questions. They always get forwarded to me. And if you have any referrals, put their name and contact information in there. I'll wait a minute if anybody wants to grab that and send us an email. Nathan asked, when you're calling a function, when do you not have to include parameters? That's actually a pretty simple thing. It's a great question. The simplicity of it is, if your function doesn't need any outside information to do its job, then you don't need to put any parameters. A function very often needs to just do some work that's the same work every time, and the work it does doesn't need outside information. For example, you may want to have a little utility program that when you send, when you tell it to do its job, it will go through every single sentence in a document and capitalize every single word. And if that program is installed in your text editor, when you click it, you don't need to give it any information. It's been programmed to just on its own grab every bit of text one line at a time and go through and capitalize the first letter of every single word. Now, that would be absurd. Maybe you're trying to make a bunch of headlines for online marketing and you want to capitalize every single first letter, but you don't always have to give it information. Does that explain that decently, Nathan? Awesome. And the same way, when you build a function, it can give information back to the part of the program that called it. They call it a return. You may have noticed that inside the actual Pong code, but you don't have to return anything. Okay, good. Now, I mentioned we record these classes, and we do, and you can find them and everything else about us at our Linktree location. It's a nice little service that just collects all of our links. If Regina, can you drop that link into chat for Linktree? And on there, you'll find links to our free YouTube video playlist with all of our free educational videos. You'll find links to our books, our dictionary, and our upcoming meetups. So, 1 second, there we go. You'll also find our social media accounts. So please follow us on social media. And please invite your friends to future meetups. I want to see more people in these classes. We love delivering them. And if you think it'll be helpful to a friend of yours, invite them. Lastly, if you want to get your own copy of You Are Not Stupid, and I'm not kidding, this book is really, really good, but it's big. It's like 300 pages or something. It's got a lot of illustrations to help you understand stuff. We give away one of these every week for free. All you have to do to be in the running to win one is just share a link to our next event on your social media and tag us. It's that easy. You can find the links at Linktree. Copy the link of our next event, put it on your social media, and tag the Tech Academy. And if you do that, we'll put your name in a hat. We pick pick a name out of the hat every week, and we'll send you an actual copy of the book. So there we go. Thank you so much for attending. Super appreciate it. As a reminder, if you filled out the form, you want to learn more about us, fill out that form and go through the steps afterwards. You can see the link again here on the screen, right? And please come to our next event. I'd absolutely love it. And come to us at the Accelerator. Love to see you there. Thank you all so much. Super appreciate it.